Programming Throwdown, episode 157, Kubernetes, with Craig Box. Take it away, Jason.
Hey, everybody. Here to talk about a really, really important topic. We've talked about Docker in the past and containerization. But one thing that's really important is, how do you run this container? How do you run it at scale? How do you get these containers to talk in concert with each other? How do you replicate a lot of these things? And so Kubernetes is something that Patrick and I both use day to day. I think I probably have to use it a lot more than Patrick does. It tends to be more of a cloud thing and less of an embedded thing, but it's extremely, extremely important being able to do all of that, orchestrate all of that, and know kind of how that works. It also, there's a large tie-in to these big cloud providers. They do a lot of heavy lifting for you. And so that makes it kind of a bit of a steep learning curve. And we're extremely fortunate to have Craig Box, VP of Open Source and Community at ARMO, and one of the people who was there on day one of Kubernetes at Google here on the show. So thank you so much, Craig, for coming on the show.
Thank you both for having me.
Cool. And so, before we, do a deep dive into Kubernetes, why don't you give us a quick background? What did you study in school? What happened after that, and what was sort of the path that led you to being on the initial kind of Kubernetes team?
Yeah, so my dad brought home a VIC-20 when I was under 5, I guess. And back in those days, obviously, it was if you want to play a game, you get a book out and type the game in. And that never really led to a love of programming for me. Is an interesting thing that I found is that as I moved on through computers and PCs and so on through my teenage years, I was always interested in making the computer do things and tying things together and running bulletin boards and all that kind of thing. But I never really had a love for programming, for actually asking the computer to do new things. It was something that I studied to some degree at university. I did a computer science degree, but I always found that the amount of effort that it took to really learn and remember the things that you needed to know to get really good at something, it just wasn't really my strong suit. And I was much more interested in being in the outside world and seeing people and so on. And so I ended up working in IT consulting roles, doing a bunch of system administration stuff, getting early on into what I think would become DevOps, so using programming concepts and having that kind of background and applying it to systems administration and so on. Moved to Canada and worked at a software company there for a couple of years doing installation and deployment.
So where did you grow up then? Probably somewhere in Europe?
No, somewhere in New Zealand, right at the other end of the world.
Oh, okay. Wow, very cool.
Through a turn of events is where I end up again today, but in the down under.
Now, I seem to remember, I mean, it's probably not true anymore, but I seem to remember that New Zealand, that Oceania, if I'm saying Oceania, but it has a really poor internet. And so you have high latency and lag spikes and all of that. Is that true? Is that kind of like it's a whole different experience being on the internet? And what's it like today? Is it just homogenous now?
The university that I went to, the University of Waikato, was the first place in New Zealand to be connected to the internet, I believe. We had a 24 or 4800 BPS connection for the entire internet and country at one point. It has got substantially better. But fair enough to say, it's far away. It's a long distance, and there are cables now. There are decent fiber cables running from New Zealand to Australia and Hawaii and so on. But there definitely used to be a sort of a culture of like what's mirrored locally. You can download stuff within New Zealand and that's free, but international traffic costs a lot of money. But as for today, it's basically we're chatting over the web today. We've got high def video and it's all flat rate. And so we've caught up, but it is in a lot of ways, New Zealand's distance from the rest of the world it's made it its own economy. One thing I remember was my father worked my father's recently just finished 50 years working. Well, he hasn't finished, he's still working, but he's been 50 years at the National Telco of New Zealand. And so I used to go around with him when I was young, and he'd go and look at the little telephone exchanges and things. And there was a rack of equipment in one of them that I remember asking him about when I must have been under 10. But it was what we call over here EFTPOS, which is basically debit cards. and being able to do electronic payments and so on. And that was actually tested in New Zealand because they say New Zealand's got this population of people that's sort of a bit disconnected from everybody else, but they're really forward-looking and they're really interested in trying new things. So sometime in the 80s, that was when they were rolling that out. They tested that first in New Zealand as to see if the technology would work.
Oh, that's super cool. Patrick and I worked at a place on the East Coast where when you were there for 50 years, you got a gold badge. Was that actually gold? Like, was there even like a
No.
laminate of gold right there? Or was just colored gold?
No, I think it was just a color.
Okay.
I asked my dad if they gave him a gold watch, and they've given him and Mum a weekend away. So that's they're going to do that sometime. Probably more useful.
After 50 years, he's earned it. Yeah.
These days, well, like if you gave me an analog thing with hands and said, "What's the time on this?" I can't do that. That's a skill that I never really mastered. I can work it out. I can look at it and say, "Well, which hand is it?" or something. But our parents' generation, they'll look at it and say it's 12:15 or whatever. Like it's an instant thing for them. But because we had digital clocks growing up, it was never really necessary, I found.
Yeah, I mean, before the show and the pre-show, we were talking about our kids, and my oldest kid is studying time, and they still use analog clocks to teach time. And so I had to go back and kind of remember, oh yeah, when it's a quarter of the way through the clock, that's 15 minutes, and all of that stuff.
I had one of those sort of shower thought moments a while back. I thought, well, if humans had evolved with 6 fingers on each hand rather than 5, how much easier would time and math have been? Because we've got all this stuff that's time and so on is divided by 6 and 12 and 360 and so on. And then everything to do with math is divided by 10 because that's how many fingers we've got. And if only those two things had been the same, what more could society have achieved?
That's true. I wonder if the base 60 thing was arbitrary. Like, I wonder what we'd have to do some epistemology to figure out what caused that.
I have 2 different thoughts on that, but we'll save them for another podcast.
All right, sounds good. So, okay, so New Zealand, and then you went to Canada from New Zealand, and so you did your first IT job was in Canada.
No, I worked in New Zealand for a few years. The thing about New Zealand is because it's such a small country, most of the people here work in a small business of some sort. There's not a lot of big companies over here. People who want to start big companies tend to go live overseas and not come back, like I did to some degree. But they say that something like 95% of the population of New Zealand work for a company with 50 or fewer employees. And so there is an awful lot of small businesses, an awful lot of farming and agricultural and tourism kind of stuff. Some tech these days, a few tech companies and startups, but it's definitely not a thing that people do. You do tend to go overseas if you want to go and work in the big industry.
Got it. And so, how did you make your way into Google? Was this like someone kind of reached out to you and said, "Hey, I know you're at IT company X. Google's hiring." What did that look like?
Yeah, it looked like a series of sort of, let's say, coincidences and so on. But I ended up working for Canada for a couple of years. We'd moved there because we didn't want to go to England, or New Zealanders always go to England. And so after 2 years in Canada, we're like, right, it's too cold here. It snows. We don't get hockey. Let's go to England. And so I went over there, worked for what was called the Symbian Foundation. It's do you guys remember like the old Nokia phones and Symbian and S60 and so on? It was a very good operating system for low-powered devices that was overtaken by the fact that all of a sudden devices got powerful enough to run real code, and you could just take Linux, Unix, and so on and run it on a smartphone by around 2007, whenever the iPhone came out. And what Nokia had tried to do around that time was basically open source the whole thing and put it into a company whose goal it was to share it with all the other vendors and to make it available to people almost as a non-profit. And that all went well until, of course, the iPhone and the Android came about. But at that job, I started doing a lot of cloud stuff. So I was getting all of our hosting infrastructure, setting that up in Amazon. All of our email and so on was with Google. We had Google search appliances. And so I was quite early on in doing public cloud things. And that led me to work at a consultancy for a few years, helping other people do cloud things. And we were partners with Google Cloud at that point, so I knew a lot of the team there. And then after a few years in that role, the Google business had sort of moved on to the point where it had a public cloud. First of all, it was the email, the Google Apps, and so on. And then as they built out more cloud things, it became sort of more in line with what I was doing, and they were sort of ready for me to join.
Cool, that makes sense. So Symbian, so they open sourced everything, and just to follow that thread, what's the longest lasting thing to come out of that? Like, has someone taken something from that and put it into something else? Did parts of it make it into Android, or did anything that you know of happen there?
It was a strange sort of ahead of its time process because I remember that there was a thing called the Beagle Bone, which is like an embedded board, a little bit like a Raspberry Pi, or a little bit like the FPGA development boards you get and so on. But like the idea was that the release team there was going to try and take these Symbian stuff and port it to a thing that everyone could play with. And I didn't really get that at the time because it sort of predated the Raspberry Pi and the whole industry of stuff that's popped up around that. But it was really just how could we build this stuff so that it would be able to be used by Nokia and largely Asian manufacturers. There are a lot of people in Japan, Sony, Ericsson were still using Symbian at that time and so on. But then all those people started using Android effectively. So the entire market fell away. Nokia used it for a couple of years' time. Nokia sort of brought everything back in house. They didn't own the trademark anymore, but they still, for the last releases that they did their own stuff in house. And there isn't really any history to that or any legacy in some strange way. It's odd because it exists. It's still out there. Someone has mirrored the code that was released on GitHub, but I have no indication that it's useful today in a way that's perhaps different to things like the Psion pocket organizers that predated Symbian. So Symbian actually derived from the software that powered those. And there is still a cult following of people who like retro computer things, who care about that. But I guess that just the way mobile phones have evolved and so on, like you hear a story about someone buying a shrink wrapped original iPhone for $60,000 recently, but you're never going to hear of people going and using them for fun. Never people in the way that they'll go and play with their Commodores or Ataris or whatever. There's not really that for mobile phones. So it is sort of a bit of an evolutionary dead end.
Yeah, that makes sense. I think the form factor, it's incredibly convenient for when you're on the go, but for your leisure time, it's not that convenient. So yeah, I think it totally makes sense. Maybe, we're just not ready yet. Maybe 10, 20 years from now, there'll be like a huge group of folks who love like retro phones in the same way we love retro computers. So it might come. I'll hold out for that.
Yeah, you've really got to think about the back end and the things that are required. And I'm sure that's something that'll come up as we talk more about what propelled Kubernetes success. Is it's all of those old computers I mentioned before are self-contained. You get a disk or you get a modern disk emulator system and you plug it in, and the software is there. And in most cases, it doesn't need to connect out to any kind of external service. There's nothing else you have to worry about. Whereas today, like if you could get an old phone running, even if you get the old iPhones, some of them don't support the modern TLS standards required to connect to modern websites. Some of them don't have the APIs that are required to talk to the modern iCloud backend. So you could get out your original iPhone, iPod Touch, or whatever, but you probably can't use it as a web browser unless you go through some kind of proxy that's deliberately made to support that. It'll be even more true of the older devices.
Yep, that makes sense. And then that's not even getting into the App Store and whether, all of your apps now require, a certain API. And so I don't know how possible it is to even get an older version of an app. It's probably not possible, or at least not easy.
I will say, where there's a will, there's a way. There's something which
It's true.
there was a device made by a Canadian company, which was sort of a cable modem attached, or a cable TV network attached microcomputer in the early 80s. And they kind of resurfaced recently because someone had been hoarding hundreds of them, new old stock in boxes that they were selling now. And so there's all of the people who are interested in old computers like, right, we're going to buy one of these. And so it turns out that they found some of the original people who built the back end service and were running it at the time. And a museum in Toronto had done a bit of work to figure this out, or it was either a museum or a university. But now there are people who are sort of reverse engineering everything required to make these things useful again and to get them going. So even these weird, obscure things, and I have to say this is largely propelled by communities around places like YouTube. Like there are the YouTube people who are interested in old computers. They get these things, they unbox them, and then 2 or 3 of them, turns out, are interested enough in programming to find the right people, connect them together, and then all of a sudden they move on from being a museum piece to a useful thing. Not something you're going to use every day, but something we might talk about on a podcast every now and then.
Yeah, that makes sense. Very cool. So, Google is spinning up Google Cloud, and you're kind of an early adopter there. And so, I guess at some point, was it the kind of thing where you were such a power user that it got their attention, or was it more of a personal connection? What kind of led you into Google?
I knew people who worked there and had worked there for years personally, But then I also was, working at a consulting company, I was helping companies adopt Google. So I was helping customers get on board largely around email migration. So you've got someone who's had 80,000 users using Microsoft Exchange, and there is some process and IT needs in order to get them migrated over to Google. And quite often there's a bit of programming and scripting required to migrate all of their systems that were using those old APIs and so on. So the company that I was working at, I was leading the development arm. So it was people were doing these workplace migrations, and then they'd need to have utilities written. They'd need to figure out how they were going to integrate some new piece of software, because the thing that they used to have with Exchange obviously doesn't work anymore if they're moving away from on-premises email and moving to cloud email. So I worked in London at this time, and I worked with there was probably only 5 or 6 people who were in the Google Cloud go-to-market team, the sales and sales engineering and so on. And there were a few more in other countries in Europe, but it was all still enough that we could probably have been on the same bus at the time. And I don't remember if it was a recruiter reached out or anything, but I sort of knew that they were looking to hire and had some conversations with them, and ended up finding a role there, which worked out well for me.
Cool. That makes sense. And so, yeah, kind of walk us through, your experience with Kubernetes, on day one. So what was that whole thing like? What kind of led to that, and how did you get kind of roped into that?
Yeah, so again, depends how you define day one. I got involved with Kubernetes when it was a internal skunkworks project at Google, and I say involved. So the first trip I did as a person working on the Google Cloud team in the UK, I went for a team meeting that was over in Seattle. And I remember thinking 2 things at this point. The first one was, we've got all these hexagon logos. Someone should really make a version of the game Settlers of Catan that uses all these cloud logos as hexagons and print it out and so on. No one ever did that. It would have been a great thing. But the second thing was, there were people around the corridors talking about this thing called Project 7, this sort of container cluster idea thing that Google was looking at releasing. I think I should look in on that. So I spent some time looking in on that, figuring out what was going to happen. And that was all development, was all happening on the other side of the world from me. But the thing we were doing to sort of help prepare customers and people to use it at that point is, as we see people, and the role I had was really talking to existing Google customers and figuring out how we could get them to do more with our products. And in large part, what we would need to do to make the products actually good enough for them to use, what things we would need to develop to make it suit their use case as we were building out the cloud. And so at that point, I was going to people and saying, hey, you should go and look at this Docker thing, but I can't really tell you why. 6 months from now, hey, it's going to get really interesting. But it was really telling people that this was the pattern, this was sort of how Google would operate things internally. A lot of the thing that drew people to Google at that early time was companies who wanted to be like Google, especially around the email and communication thing. A lot of these companies saw Google as this great multicolored university campus, land of milk and honey or so on. It had what they perceived to be really high employee satisfaction and was this really cool and innovative place. And a lot of these more staid enterprise companies thought, well, hey, if we just change our email system to the same thing that Google uses, maybe we'll feel a little bit like Google and have a bit of that rub off on us. So
Nice.
technically, I think it was sort of the same thing as, like, a lot of people thought, hey, we're going to use the same system that Google used. And I would not recommend that to people, obviously. There is a reason that these big organizations grow their own internal system that fits exactly the space that they have. But the thing that Google was doing was taking lessons that learned from that and trying to build something that was general and could be applied to everybody else. And that was really when you hear people talk about Borg, which is the internal system at Google at the time. It wasn't just open source that thing and make it available to everyone. It was build something new that met people where they were at the time.
So let's like pause a little bit on this. So I vaguely remember Borg. So I remember there's something called Borg control language. It was like a dedicated language. It was very similar to Python. I mean, this is going back a decade, so my knowledge is really fuzzy. But
yeah, do they, like, when you get assimilated, they wipe your memory or something, so you may not remember?
Yeah.
Borg was developed at a time when people had just obviously come off watching a very particular series of Star Trek, which had been on TV. And so then when it's been in use for 10 or 15 years, you've got all these new students coming in like, what the hell is this Borg thing? Like, I know what the software is, but I don't get the joke.
Yeah, exactly. Yeah, and so I think, you'd specify everything in this Borg control language, and then it would go off and do that thing. And so, now that I'm kind of putting it all together, it is similar. So was Kubernetes it was probably a total rewrite. It wasn't the kind of thing where you forked it.
No, Borg was written in internal dialect of C++ that Google used to its standards of the time and so on, and to fit a very Google-shaped problem. It was an evolution of things that came together. A lot of the people who did that work and who worked on the subsequent system, Omega, which was sort of a second system attempt, if you want to rewrite it. Second systems don't go very well. We've all read the book, I hope. And so a lot of that work basically went into making Borg better overall. So that's another interesting evolutionary dead end we can talk about. But some of those people were involved. So you hear names like Brian Grant, who was one of the leads of Omega, and Tim Hocken worked on the low-level stuff in Borg, and Dawn Chen, for example, people worked on very early days in the Borg system, were one group of people who were looking at how Google could solve the problem of making something like this available to cloud customers. And then on the other hand, you had the cloud team and people who had worked on various things in search and so on internally and had moved on to the cloud project. And they were looking outside at the rise of Docker. They were saying, well, people are all of a sudden starting to do things a little bit like Google is on one hand. So that they're using these container principles and so on, which were largely popularized, if not invented in part by Google to make Borg work. And then there were also people on the outside who had built Borg-like things, people like yourselves who had been at Google, gone somewhere else and said, hey, I missed that system, which made it really easy for me to deploy things at scale. I'm going to build a version of this. One of the most famous ones is Mesos, which was built by people who had interned at Google or had worked there and then studying at UC Berkeley, gone on to work at Twitter and so on. And they're like, well, we need something like this. And collectively, I think the Twitter people found the Berkeley project and said, all right, we're going to work together on this and build something that was sort of very similar. And so the team of people who were working on the cloud side were people like Joe Bader and Brendan Burns, and they were building proofs of concept and sort of sample projects and so on to say, all right, well, how could we do something based on Docker that worked in this kind of way? And really, it was when those two teams came together, when those groups of people said, all right, we can do things, we know how it was done at Google at scale, and more importantly, why it was done, then that can be made useful. And also, I think the input of people who didn't ever use that system, or people who knew what was going on outside, and like to say, Google at that point as a new entry into the public cloud infrastructure market, they really needed to make things compatible with what people were using, and they couldn't just determine, here are the terms, or dictate the terms if you want, to say you have to use these APIs and do things in this way that people like Amazon could do at the time.
Yeah, that makes sense. So these sort of great minds came together and formed Project 7. And at some point, I guess, was there like a meeting that you went in, like a dark room, shadowy figures, altar in the center of the room, and they introduced you to Project 7?
No, as again, you two may have seen, like the way you learn about things at Google is you just find the design document and you follow along and read what's going on, and you join mailing lists and see what happens. One thing I will say is that I was always very separate from the teams at Google, especially in the cloud division, who were doing all the engineering of this stuff. I was based in the UK for almost all of my career at Google. And the work that I did on this was largely like whenever people wanted to find out what was going on, how real customers wanted to do things, or real use cases of this kind of stuff, that quite often the engineering teams would come out to Europe and they'd say, right, we want to talk to a bunch of customers. And I would know who I'd been working with and so on, and connect these people together, bring a lot of feedback, do a lot of demonstrations and public events and so on, and bring my own feedback. And that's sort of how that led me into developer relations and developer advocacy kind of roles. But then I ended up, as we productized that, as we moved it from being this open source thing to being Google Kubernetes Engine, or GKE, I ended up in sort of go-to-market lead roles and helping out how we can productize some of this stuff and how we can really figure out what customers want and need, and put together events at KubeCons, for example. We used to do these customer advisory boards. We would get the really early adopters who were really keen on this and talk to them and figure out what we needed, and then get the things which the next group of people would just find standard in a year's time, and keep that process running.
Yeah, got it. That makes sense. So just so I understand the timeline, so there is like Docker Compose. Did that come out after Kubernetes, or what's the story there?
No, Docker Compose, I'm going to say it came out before Kubernetes. And Docker Compose is a way of saying, I want these 3 or 4 containers, or however many, to be co-located together on one single machine. So my application, my 3-tier thing is made up of these 3 things, but they're in different containers. They all run together in one place. the thing that actually distributes them and runs them across multiple machines, there was a thing called Docker Swarm. And I have a suspicion that came out at or around exactly the same time Kubernetes did, because in the early days, it was sort of announcements were made at Docker's conferences. There were 3 or 4 systems that all came out around the same time. Some of them were in-house systems from various vendors. Spotify had one called Helios, for example, that were, again, like, hey, we've got this great Docker engine which allows us to put things together in containers. Now we need a way to manage the lifecycle of them across multiple machines in the kind of way that we know that Borg does. This is before it was ever publicized, or a big deal was made never to mention the thing by name outside, for example. But again, lots of people had come and gone through Google. And
Yeah.
I don't know if we were more worried about Google's lawyers or Star Trek's lawyers at that point.
That's true. Got it. Cool. Okay, that makes sense. That kind of I've seen Docker Compose. I've used it occasionally, but I've never written anything in it. It's more just if I'm looking at some open source GitHub project and they're using, I guess, Docker Swarm or Compose, whatever it is. But definitely, I've spent the vast majority of the time on Kubernetes. So yeah, I think maybe now's a good time to kind of explain to the audience, what is Kubernetes according to Craig.
What exactly is a Kubernetes? Well, yeah, so Kubernetes, well, for starters, it's this weird Greek word that no one can even agree on the right way to pronounce.
Wait, really?
But
I didn't know that. I mean, it kind of makes sense. Yeah, it kind of
it's all
makes
Greek to
sense,
me.
now that I looked at the phonetics. So what is Kubernetes, the Greek word, actually? Is it a person's name or?
No, it is. This is going to blow your mind, Jason, but it is. If you think about the word cybernetic, kybernetic, or if you think about governance and governing something, the word gubernatorial. So these all come from the same Greek word Kubernetes, which means helmsman. It means the person steering a boat. So someone, like, you think of the command and control sense, like governing something or so on. That is where the idea of sort of cybernetics came from as well.
And that explains the icon as well, because the icon is, if I remember correctly, the icon for Kubernetes is like let me see if I can look it up. It is like a wheel like thing. And yeah, exactly. I'm looking at it right now. I mean, this is terrible radio, but take our word for it, or go look it up. The Kubernetes icon is like a 7-sided polygon.
It's a helm. It's the helmsman, like the helm of a ship, the steering
No,
wheel.
well, that's the wheel, but I'm saying the blue part. Heptagon. Okay, I didn't know that word.
Heptagram would be the star. Heptagon. Yeah.
I'm totally So it's for folks out there listening, it's a heptagon, a blue heptagon with like exactly, a ship's wheel in white.
Yeah, so the helm logo, the wheel, ship's wheel on the logo obviously refers back to the name, and the 7 sides is the Project 7 code name of Kubernetes from before that.
Oh my gosh, how did I not put that together? So yeah, so actually the Project 7, were there 6 other attempts? Because I mean, there was Borg, there was Omega, were there like 4 other attempts before they went to Kubernetes?
Did you two watch Star Trek in the 80s and 90s?
I am not a Trekkie. Patrick, are you a Trekkie?
Yeah, I did always understand the reference to Borg, but I missed that other folks missed it. Oh, wow, that was double. Oh, sorry. I never paid attention that people probably didn't know what it meant. So that was probably an astute observation.
It's not only the Borg thing, it's that, and I didn't watch it myself, but I think it was Deep Space Nine. They had this Borg character called 7 of 9.
Oh.
And so that's where the 7 thing comes from. The idea was it was I think they pitched it, and I apologize for this, as a prettier version of Borg.
Oh, I see. Got it. Interesting. So now, folks at home, the reason why Kubernetes logo is a heptagon is because of 7 of 9 from Deep Space Nine. That's amazing. Okay, so we got as far as the name. So sorry, I got us totally sidetracked there. So what is Kubernetes for folks at home?
Kubernetes is a management system for distributed systems. It is based around running containers, but that need not be the only thing that it does. It is a cluster system. So the idea is it manages things that run in multiple places that are disconnected from each other. And it works in a model where you submit to an API server what it is that you actually want to have the state of your cluster be. So it's a declarative system versus what you may have used before, which is imperative, where you say, please make this thing happen. You say to the system, I would like this to be the outcome, and you leave it to decide.
And that was one of the things that really blew my mind about Kubernetes. And to this day, I wonder how it what happens when it can't diff something? Like what if you provided a YAML file? Actually, just to backtrack a little bit. So the way that this is actually implemented is you provide a YAML, which is similar to JSON or one of these structured files. You provide a YAML file to the Kubernetes API and say this is the state of the world. And so it looks at the current state, looks at your YAML file. And the thing I was always wondering, I'd love to get your take on it, is how does it know how to go from A to B? Like, what if you just do something really, really different and it just can't seem to get you there?
Well, if you think about the common use case again, so you have a Kubernetes cluster which has an API server, and then it has a number of worker nodes. So it has these places where it can ask computers to do things. You will give the API server an instruction that says, I want to run a web server. And you give that to the server, and it says, all right, well, I know I've got this many machines because they all report to me regularly and say, here I am, and this is what I have running on me, and so on. You have asked for a web server. You've specified that it needs to have 2 CPUs and it needs to have 256 megs of RAM. So probably not going to be hard to find somewhere in the cluster to put this, but you can get larger workloads and more of them and so on. And then knowing what it knows about the state of the environment, it'll say, right, I'm going to ask this node to start it over there. And it'll send that instruction out, and then it will update the status to basically say, I have scheduled this thing. I've asked it to run. It passes, or it actually puts an object there. When the node checks next time, it says, there is new work available for me. I have been asked to do a thing. It will then start that running. If it can't start that running, it will update and say, I couldn't do that. Perhaps you asked with a container image that you spelt wrong, and so it couldn't do it. It says, enters the state that it calls a crash loop backoff, which is the most fun thing for anyone involved in Kubernetes to have to debug. But that's basically saying, I couldn't do this. I'm going to try again. And it waits a little while and it tries again. And if it fails, then it waits a little while longer and it tries again, and so on. So you can get into situations where things don't work, but basically it updates the status of the object to say, I couldn't do that thing.
Yeah, that makes sense. Yeah, I think the schema of the YAML is kind of like I'm sure there's some way where you can trick it or get it confused, but in general, you're right. I mean, most of the time someone says, here's a YAML, and so it just creates a bunch of stuff. And the next time around, here's a YAML, and like now I'm using 2 CPUs instead of 3 CPUs. And so it's like a relatively straightforward diff.
Yeah. So there's 3 different parts to an API object in Kubernetes. So you have the metadata, which is things like the name of the object and then any labels that are used on it. Labels are important because that's sort of a way you do queries across things that there can be more than one of. And then you have its spec and its status. So the spec is what you actually want. And in the case of you want to run containers on an environment, it'll be wrapped up in a thing called a pod. A pod is the minimum unit of scheduling of stuff in Kubernetes. It can have 1 container in it, but it can have more as well. So you might want to say, these 2 containers always run together. This is my web server, and this is the agent that processes its logs, or it gets the files to serve from Git, for example. Those 2 things are always required together. So the pod is the minimum unit of thing that you schedule. So for a pod object inside Kubernetes, you will say what the specification is, the spec, and it might be that it has this particular container image, and it has this much CPU and RAM, and it has these security settings, for example. And then the status object should effectively say the same stuff, but it might turn out that you've made a change and that hasn't updated yet. And so if you make a change, it will do some magic diffing and so on and say, all right, well, I'm submitting a new object with the same name as the last one. What are the things I need to change? I need to make a change to its labels. That's just an API server thing. I need to give it more CPU. Well, in that case, what I need to do is tear down the old one and instruct a new one to run and so on. So there are possibly some cases where it can get confused, and it'll probably just mark it as, again, crash loop backoff or something and put a log entry as to why it is. But it's quite uncommon because of the structure of only a few different things that matter inside each object that you can get it so confused that it wouldn't be able to do anything. I've never really heard of that.
Yeah, that makes sense. One of the things that blew my mind with Kubernetes, or one of the things that was really surprising, was I kept seeing M core everywhere. I was like, what is this? Finally, I looked it up, and it was milli-core. So you can actually say, like, I want this process to use 1/400th of a core or something. Like you can get very very specific, which is really good because you are running these things at really large scale, and you need to be able to coordinate and orchestrate.
All of that speaks to the reason that Google wanted this kind of system and the reason that it thought Kubernetes would be relevant to people. And this is something which is I find very interesting. The reason that Google wanted to do this kind of thing is it's not running one instance of a web server. It's running 20 million. It's running whatever big number you can think of. Like they used to talk in public conversations about a small cell would be on the order of tens of thousands of machines. And you might deploy something like the backend for Google Calendar, and you're going to need tens of thousands of replicas of that. And you just think, well, if we assume the backend for serving any application takes a couple of hundred megs per user or something, and there's millions of people concurrently hitting it from every country in the world all the time, you need an awful lot of stuff for this kind of scale. And you also need to have that for anything new that launches on day one. Google never had the luxury of saying, all right, well, I'm going to launch a thing quietly, and then, unless it was on some kind of wait list, everyone in the world knew about it immediately and everyone would come and hit the thing. So you need to scale things up pretty quickly. But that's very expensive. Like you've got to run millions of replicas of things and over the course of time. And so they wanted to be able to pack more things into the fewer number of machines. So it's not so much I have 10,000 calendar backends and I need one machine each to run them. I need 10,000 machines. It's, hey, I can schedule them on a smaller number of machines, or in the space that I have left over when these things aren't doing anything, I can run batch workloads and so on. So the real reason that Google had for having Borg was to get more out of the number of machines that they had using this API system that drove it all. And that was the thing that we thought people would want to use Kubernetes for. People would want to do more with their infrastructure. Famously, we talked about the reason that we launched it at the time was when the people who had been building Google Compute Engine, Craig McCluskey, who was one of the PMs on that, who went on to launch Kubernetes, they would go to the Google backend team, basically, and say, all right, hey, we're selling out of this compute stuff. People are buying it. We need some more, please. And they'd say, well, hang on, you're only using 5% of the CPU. Say, well, that's fine. We sell these CPUs to people. They buy 100% of a CPU. They only use 5%. They're paying for the whole thing, but that's what they're using. And that was just so anathema to how Google thought about things. Like, we need to pack more, and you should be able to get 70, 80% utilization out of that CPU, because you need to do that at that kind of scale. But it turned out that the thing that people actually couldn't do back then, and remember this is around 2014, is they just couldn't deploy software. They couldn't reliably say, hey, I want to run the thing and have 10,000 copies of it running and start and upgrade them and so on. Like simply just having an API that enabled doing that, you could be as inefficient as you want in the first instance. That's a problem we'll solve later on. We just can't make our thing run. And that was the thing that really got people interested in Kubernetes, was it was just a really well thought out declarative API for managing software at scale. The fact that you could then later on at scale say, I'm going to only use 400 millicores for this rather than a whole CPU or something, that's a nice to have that people can get to later on.
Yeah, I mean, one of the things that I remember a story, I'm not going to say any specifics here, but there was a time where, we were running something, there was a team running something at Google, and basically every time someone made a request, it created a thread, like an OS level thread, and it never closed it. And so after maybe 10, 20,000 people hit one of these endpoints, it would crash because the OS would just run out of handles. And it ran for years like that because Borg or Kubernetes under the hood just said, okay, well, this one crashed, let's spin up another one. And it always had enough running that, that we didn't have to worry about that bug for a while.
Yeah, there are many different ways to succeed.
Yeah. And that is something that I think, it ties into a conversation I was having a little while ago with somebody where you can make the case that what really matters to your company are your KPIs, your key metrics for your company. I mean, as engineers, like it pains us to see unclosed threads, right? And it was eventually fixed. But the time in between when people were fighting other fires that were really making big gains in the company metrics, that was made possible because Kubernetes was able to throw them that life preserver. And I think to your point, it's like just the out of sight, out of mind of these like massive replica sets allows you to really prioritize things that you wouldn't be able to otherwise.
Yeah, there's a lot to be said about, like, you can be inefficient, but you need to be up. And when people started thinking about SRE concepts, which were sort of publicized by Google around the same time as Kubernetes, it enabled the industry to understand the difference between an SLO and an SLA. A lot of people in enterprise think, oh, I've got this SLA, which says basically, all right, well, the company will give me back some money if they're not online for the amount of time that they say they will be, and normally measured in sort of percentage of uptime. But the thing that actually matters is being able to say, here's my objective. I hope to be up for this amount of time. And the SLA is really only the monetary piece on top of it, is to say, all right, this is what I will give you if not. And so then you need to know how you're going to measure those things. You need some sort of indicator. And your internal teams can say, all right, well, hey, if we are meeting these goals, we might be burning money to do it, but we're meeting the goals, and that's important. And it might be that how much it costs to fix that costs more than the amount we'd have to pay out in the course of an SLA breach, for example. So you need to factor these things in holistically, and you need to look overall at the costs of running things, especially when they're in a sort of pay-as-you-go cloud environment, if you want to be a successful business.
Yep, that makes sense. And yeah, to your point, people get so bogged down in deploying software that they couldn't focus on the part of the business that makes them successful.
Mm-hmm.
I mean, yeah, before Kubernetes, I mean, just so many horror stories. I mean, I have a quick one. This is not from Google. This is from another company. This person told me that they had a Java jar file. And for people who don't know, a jar file is literally just a zip file with Java bytecode in it. And the way that they were deploying their software was they were taking their Java bytecode, their .class files, and they were unzipping the jar file, putting them in there, and then rezipping it on the production server. And so at no point did anybody know what the code on the server was, because everyone was doing this concurrently. And so, yeah, I mean, this is what people were doing even in 2014. I mean, I think we forget so easily with Docker and Kubernetes. We forget how hard it was to deploy things and what sort of wonky things people did when they didn't have any other way.
That said, I run a website which is running PHP code from pre-year 2000 probably, and largely hasn't changed in that time. And I'm not going to tell you what it is, because I'm sure it's full of security holes and you'd really be able to take it offline very easily. But it still works, and there's a lot to be said about it. I'm never going to put it in a container, and I'm never going to change anything about it, because it's just a thing from the past that it pleases my heart that it's still there. And there's a lot to be said about things that were really easy. Like the whole idea of things like PHP made it possible just to FTP a bunch of stuff to a server and have it work. And simple is useful on one hand. There's a whole bunch of complexity that's introduced. We could go on for hours about the trade-offs here. It's like Kubernetes is complex, and it's got all these bells and whistles and so on. And there are easier tools, and what is the right thing to do? The answer depends entirely on your use case. And it's an investment question as well. It's like, do you want to be in the ecosystem where you can hire people who understand Kubernetes and can work on stuff from day one? Or do you think that by building something in-house for you that you perceive to be simpler, then you're going to be able to win in the long run? You have to make these, and they really do come down to being business decisions.
Yep, that makes sense. One of the things that I think Kubernetes saves people a lot of time and ultimately money is the way that the different containers, or the instances of the containers, can talk to each other. So I mean, that was one of the things that really is very intuitive to me. Is in your YAML file, you name this replica set, I guess is what's called, or this process. You name this database, and then in your actual application code, you can say connect to data, like HTTP:/database. And so under the hood, Kubernetes knows, oh, database actually means this other part of your deployment. And I thought that the whole networking part of it was extremely well done for something that's really complicated.
This is another huge difference from Borg. The way that Borg worked is it ran a thing called the Borg name service, where everything that started up, your 10,000 calendar instances, would all register with the Borg name service, and then the load balancer or whatever it is that needs to know where these things are would have to have a client library that knew how to talk to that service, and then it would say, all right, where are the backends for this, and it would get back its 10,000 requests and so on. And it could, in theory, this I think was implemented a bit later on, but this system basically could say, not only here are 10,000 replicas, but here's how busy they all are. And so it could then be used to make load balancing decisions based on utilization, for example. And that worked, but it required you to write custom software for everything. The internet as a whole has a way of finding out where a service is running, for better or for worse. It's called DNS. And so the difference in how Kubernetes operates is it basically has a programmable DNS server baked into it. You create an object, a different object inside Kubernetes called a service. And then we go back to those labels we talked about before. We've got deployed labels on top of everything and say, this is a calendar, name equals calendar, version equals 2.0, samples equals dev or something. And so you can make a service that says target all of the things that are the calendar, or you can make one that says target all of the things that are the dev version of the calendar, or the dev version at 2 or version 3 or so on. So you can target which those things are and select that group. And then you can associate a name with that. And so you might say connect to dev calendar service, and then it will return you the IP addresses for that whole list of things. And then your software can decide, does it round robin between them or whatever it wants to do. But it just does that with DNS. And the benefit is that if you have software that has no idea it's running on Kubernetes, it just works. You say Nginx is my load balancer, balance between these services, like it knows how to do that. You didn't have to rewrite your front end. You didn't have to compile on any kind of Kubernetes name server thing to work. Everything kind of worked the way you'd expect it to.
Yep. Yeah. Super clever. I mean, one thing that on the flip side, one thing that at least I found as a user of Kubernetes really complicated was ingress. So, Kubernetes, because it has its own DNS server, it's almost like its own, intranet. And so then when, you, Joe Schmo on the outside wants to talk to a Kubernetes service, now you get into like cluster IP and node port and load balancer and which do I pick and why and oh, it doesn't work.
And you know why this is a problem? It's because we haven't all moved to IPv6 yet.
Yep, that's right. If it was IPv6, we would just
that was not a serious suggestion.
Well, but I mean, yeah, I actually love IPv6. I don't know enough about why we don't have it yet. I mean, I'd love to get your take on it. You probably know a lot more than I do, but it would solve a lot of problems.
I think the answer is because IPv4 works and people are incentivized to keep it working. That said, Kubernetes now does support v6 largely, and so do all the cloud vendors. But I think that while v4 is good enough, then it's going to keep being the answer. But I will explain what I meant by that. So first of all, you mentioned it's a bit like an intranet. It is a cloud in and of itself. Like it has APIs, it configures, you can start things running. It is, to all intents and purposes, as complex and does all the same things that a cloud vendor does, that OpenStack did, that Amazon or Azure or Google do when you say create me an instance of things. So you have to think about it in terms of that level of complexity. And then you also have to think about it in terms of the complexity of how am I going to layer Kubernetes on top of a second cloud and so on. In order to solve these naming problems and make everything work with DNS like we talked about, one of the very early decisions that was made with Kubernetes is that every pod, those things I mentioned before that are one or more containers together, every pod in a Kubernetes environment needs to have its own IP address. To give it a DNS record, you need to have an IP address, for example. So there are not enough internal IP addresses in some companies, I'm sure Google are included, to do things at that kind of scale. And there are not enough RFC 1922, or I hope I got the number right, addresses to not conflict when you have enterprises who are running lots of different clusters and so on. So you need to have these little islands of natted environment, if you will, like many businesses already have. And to get from the outside internet to that, you need to have some sort of gateway. And that's effectively what an ingress was. It was the idea of being able to define a programmable gateway to say, someone on the internet is going to call onto this. They're really only going to need to hit one or two IP addresses like they were before in an enterprise situation. But then that needs to fan out and be aware of everything inside and be able to make calls into my natted environment. So when you think ingress, like for anyone in the old world, you think NAT, it kind of works the same way. It would be great to say there was a world where all of those IP addresses inside Kubernetes were globally routable or were available everywhere. Some people may choose to run their Kubernetes environments like that. That sets you up to all of the problems that you have with other networking, where you think, all right, I all of a sudden have to worry. All these things I was running internally are now possibly internet addressable, and you really have to think about security. You got a lot of free security by running gateways and nets and so on. So it's possible. It would be more possible with v6, but it's something you really have to pay attention to.
That's a real. Actually, I want to pause there for a second. You're totally right. I mean, even if we had IPv6, for security reasons, you'd almost certainly still have a NAT layer, and then you're back to the same problem.
Well, you've got to have a firewall layer at least, but I think v6 was designed in the 80s, back when the internet was still very academic, and the idea of everyone running services on their own local machine and so on was well accepted. But we've very much pivoted to a world where you put your servers and your hosting in a server hosting environment, and anything I'm running on my local machine is more likely to be something I'm developing or something that's insecure. And I don't like the idea of anyone on the internet being able to route to things I'm running locally. There's the trust situation, the threat model has changed substantially since it was defined. And maybe that's one of the reasons why people think, well, hey, that's a huge advantage of v6, which it actually turns out not to be relevant in 2023.
Yeah, that makes sense. Okay, yeah, so that makes sense. So basically, you don't want to make every pod accessible from the outside, and so the services that you do want accessible, you have to set up an ingress rule, and that's where you get into those different variants, node port and cluster IP, and all of that stuff.
Yeah, and all of that basically relates to how does the machine, the pod that's running the ingress on, how does it talk to, how do you expose those things? And it might be that you have an external load balancer that's sort of unaware of the Kubernetes environment, and it just has to say, here are the cloud IP addresses of some machines. Do I make that service available on a named port on a numbered port on the machine that I can then route to, or does the ingress run inside Kubernetes and it can just use the objects? Like, it was harder over time. Now the ingresses and the load balancers that power them and so on are generally more aware, and the cloud providers are able to expose the internal Kubernetes IP addresses to their load balancers. So these were things you had to worry about a lot in the early days. They were just, how do I route things and deal with the fact there might be 4 or 5 different things on my physical server machine, 4 or 5 different Kubernetes pods, who all think they're running a service on port 80. And only one of them could run on port 80 of the underlying machine as far as the external network was concerned.
Got it. Yeah, that makes sense. Cool. So if somebody wants to, get started, let's say I have, maybe we'll use your example. I have a PHP site and I have a, Postgres or MySQL, backend, and I've decided I want to take the plunge, move this onto Kubernetes. What do you recommend for people? Like how do they learn Kubernetes, and then how do they, get started quickly?
It pains me to say that I don't know. And I think the answer might be I don't know anymore, because like one of the things that I did in the early days at Google was help contribute to producing courses on how to learn Kubernetes. And they basically start by saying, here's a pod and here's how you run it and here's how you expose it and so on. And they leave a lot out at the beginning and at the end. The bit they leave out at the beginning is, how do I actually get my stuff into a container? If I have a PHP application today, I upload the files or I edit them on the server and so on. They are there. They are not, they're on the same machine as the web server, but they don't come packaged with it, because I just use the server's package management system to install PHP and Apache or Nginx or whatever. But so then you need to think, well, how am I going to get the engine? And then how am I going to download the files that need to be with that to serve it? And how am I going to group those things together and then deploy them? And so the first thing I would sort of suggest to people is this a thing you need to do? Like, are there services, like you can use Google Cloud Storage and Amazon S3 and so on to do static hosting really easily? Hosting files without running a server to do it yourself is largely a solved problem. And there are also functions, containers as a service solutions and so on, that if you just have a container that serves stuff that you want to upload, they can handle all the scaling of things for you. So one thing I would say is, if you have that sort of desire to do a thing and learn it, that's great. And if you know that your problem is going to scale and need this kind of thing, that's great too. But the first thing I would say is figure out if you have a Kubernetes shaped problem, because you don't need to use that for everything.
Can you double click on that? So So if there's a service that takes your container, runs it at scale for you, where's the gap there between that and Kubernetes?
So there's a value gap. First of all, the vendor who does that will charge you more for that because they are solving a problem for you. And then you lose a bunch of control. You don't know where it runs. You can't necessarily say, I would like this container and or this pod and that one to run on the same physical node because I value the fact that they are close together as far as latency is concerned and so on. So you get some trade-offs, but then it's sort of a convenience. It's like Heroku versus running on your own server or anything like that. You can do these things. You can operate in a shared environment. You can get some economies of scale, but you lose the control.
So what is that service called on GCP? The one that runs your container?
Yeah, Google Cloud Run. Google Cloud Run is sort of like a second version, if you will. There was a thing called Google Cloud Functions, first of all, which was basically upload some code, and that in itself was, you two may remember, App Engine. There's been an evolution of sort of upload code and it'll start a server and run it for you, to upload code and it will sort of build a container and run it for you somewhere, to upload a container and then it will run it for you wherever.
Got it. Okay. And so we have kind of a little set of stepping stones here. So, and again, you're totally right. People should not put everything into Docker and Kubernetes like rote, right? I mean, there should be, reason. But let's say it's an academic exercise and someone's kind of motivated to do it. So then the first step is, get your thing running in Docker and basically stop your web service, Docker run your container and make sure it does basically the same thing. And that's maybe, step 0 here. And then step 1 would be run on Google Cloud Run.
Yeah, let's back up a little, if you would. When you talk about any kind of migration, you quite often talk about lifting and shifting a thing and then improving it to make it work. So in our example before, we've got a Postgres backend and a PHP web service or something. So let's look at the database. Like, you can just say, all right, I'm going to stop my provider, my apt-get install Postgres. I'm going to shut that down, and then I'm going to Docker run Postgres instead. So now all of a sudden, I just have to worry about a slightly different life cycle and how I deal with the data and so on. But largely, I'm still doing the same thing that I did before. So that's the lift and shift part, especially if you're moving from, say, on-premises to a cloud while you're doing this. Then the next piece is, all right, well, could I just use some sort of magic backend hosted database service? You still end up with a database that's running on a single machine, or you're clustering it so it runs with replicas on many different machines. But there are now services that basically have magic distributed backends and can speak the Postgres protocol and so on. So you may eventually decide the management of applications on Kubernetes is hard enough. The management of data, where you have to worry about, like, this is a disk image and it may be big and it may need to be reattached to a different machine if the scheduler says, hey, this node's coming down, I'm going to run somewhere else. We didn't really touch on the sort of redundancy features and high availability and so on, but you need to be able to handle your workload moving around, and that gets more complicated when you're dealing with it having static attached data. Kubernetes has principles for dealing with this, but like, you may decide, again, from business reasons, that I just don't want to worry about that. If you are running at big enough scale, or you want to run on premises, you don't have that kind of cloud service and so on, yes, you will want to investigate that. But I don't think there is a simple, there is obviously, here's how we do it in a lab environment, but there's not one answer. And it's so frustrating. We used to have the same problem. People would say to Google, like, I want to store some data. Like, great, we've got, and again, I don't work at Google anymore, so please excuse me if I get this wrong, but we've got Bigtable and Spanner and Cloud SQL and Cloud Storage and Firestore and whatever. It's like, well, you've got to go through a decision tree and say, well, what kind of data is it? How frequently is it going to be accessed? How frequently is it going to be rolled? And do people want to query it by column or by row and so on? You've got to think about these things. Whereas a lot of people who are just dealing with fun stuff at home is like, well, MySQL can deal with all of that as long as you've got under 100 megs of data. Don't worry about it. Good problems to have.
Yeah, good call out. I think actually, can you double click a little bit on that? You touched on something there with the persistence. I think so. A Docker container, just for the audience, is read only. It's not like while Docker is running your container, you can go and modify the container itself. It's like you created this frozen snapshot, and so if you need to persist anything, it has to go somewhere else. And if you're web server, that's usually a database. But if you're a database, now that's not an option. So So yeah, how does that work?
Yeah, so what you said is true enough. It's true in the sense that like a VM image that you instantiate, that image is read only, but once you've instantiated it, you've basically copied it to a disk and so on. But you can attach writable volumes to a running container. And so the way that you handle this in Kubernetes basically is you say, I need to have a certain amount of disk, and the abstractions that Kubernetes provides say, like, I would like to have a 20 gigabyte volume or a 2 terabyte volume or whatever. And then because Kubernetes knows what it's running on, it's configured to run on top of your cloud or your OpenStack or VMware or whatever environment. It calls out to the underlying system and says, give me 2 terabytes of whatever your flavor of disk is. And it also has storage classes that you can configure to say it can be SSD backed or it can be spinning disk or whatever. And then it will attach that volume to the machine, because remember, underneath this all is still VMs or computers, basically. So it does whatever network attachment tool it has. Or you might say, I want a local disk, and this thing is like useful for cache data, but it's not a network disk, and that's there straight away. And then it maps that through so that is accessible at whatever path in your container. So you just have to say, as the person who's written the app, write to /data, and then you trust that Kubernetes will have mapped something there to you.
How does that work with replicas? Like, let's say I have, yeah, 3 replicas and they're all going up and coming down at the same time. Like, yeah, how does that work?
So what you want to do is to have the data persist, but you also now have to have, like, it's not just enough to say this data, like you have replicas 1, 2, and 3, and you actually have disks 1, 2, and 3, and they have to stay associated with each other. You can't just move the things around; it'll confuse things. So this was something that got added early on in Kubernetes. So you talked before about replica sets and so on. That's a way of saying I just want n copies of the same thing running wherever. If you want to say this one is important and it's ID number 0, and the next one is ID number 1 and it's the first replica, and so on, there is an object called a stateful set, where you can basically say all the things in this have an order and they have disks which will be assigned in that order. And if things get moved around, this disk and that particular volume that particular pod will always stay together and they'll be moved together. And if it is shut down, it gets rescheduled somewhere else. The system underneath it will say to the disk controller, I need that named volume, not just any 2 terabyte volume. I need that one because that's the one that's got my data on it.
Oh, makes sense. Yeah, that is a huge amount of complexity. I mean, with Docker locally, you can mount paths on your local machine, and that gets you pretty far. But the same thing, if your machine dies, then you're out of luck. With something like Kubernetes, you're protected from that.
You can be, and again, it's a configuration choice. We haven't begun to talk about security as well. Like there are so many different knobs here that you can turn to do things, but it doesn't. It's a toolkit that you can use, and some people have published some patterns as like, here's a good way to manage databases. You might hear people talk about a thing called an operator in Kubernetes, and that basically is a piece of software that knows how to manage another piece of software. And so, for example, it might be, let's talk about Postgres again. You might say, I want a Postgres database, and then you create a custom Kubernetes object that the operator has provided for you and says, give me a database of this type and with this many replicas and so on. And then it knows how to translate that into instructions to create this stateful set and to set up permissions and so on, and deal with that. And it also adds application specific things, like you might want to know how to back up an application. If you just say, hey, back up to this particular operator, how you back up Postgres is different to how you back up MySQL or etcd or anything. So the same kind of patterns, especially around databases, exist and they're out there. But then again, there are also 5 or 6 different people who make Postgres operators. So you have a world of choice, and there's not always a golden path.
Cool, makes sense. So is an operator like a macro for Kubernetes? Is that the right analogy, or is it something else?
We've talked a lot about controllers in the sense that you upload an object to Kubernetes, and then the controller is the thing for a replica set or whatever that takes that object and actually does the thing. An operator is the combination of a custom object and a custom controller that relate to a certain thing. So you could sort of think about it as a macro in the really old sense of like word processor macros or so on. But it is a convenience thing that's sort of custom to take those things that are not just for, like, the built-in controllers operate containers, the operators operate databases or things that you might want to stamp out more than one of a thing.
Cool. Yeah, that makes sense. Oh, Another thing that I found useful when I was learning about Kubernetes was the local Kubernetes. There's Minikube and Kind and these other things where you can run a sort of like a very lightweight Kubernetes on your own machine. What's your take on those? Is that a good pattern for people to follow when they're getting started?
Yeah, again, there are lots of different ways you can do development kind of work. You can say, I'm going to run a local Kubernetes cluster and test everything against that and then do integration somewhere else. Or you can say, I'm going to run a development Kubernetes cluster for my team, and every member of my team gets their own slice of that cluster to do work on. It is pretty easy to do a combination of those things if you are using or paying for the Docker Enterprise or the Docker Desktop product. Sorry, they have built-in Kubernetes. You've got Minikube and so on, which are VM-based things that can run locally. They give you effectively a single node Kubernetes environment, but that's enough to test a lot of things and to say what does it look like, especially if you're taking an application that wasn't Kubernetes aware and putting it in this environment. It is a good start. It's not going to deal with the fact that moving from monolith or local application to a distributed system, all of a sudden, things that were function calls that would guarantee to succeed are now RPCs that might fail or might time out or anything like that. There are lots of things that you have to think about that even running Kubernetes locally isn't going to replicate, but it's a useful tool in the tool chest.
Yeah, it makes sense. And you touched on this a little bit earlier. I wanted to go back to it. Securing Kubernetes. I mean, you have a NAT, so that's providing you some level of network security. But what are other things that folks should have on their radar when they're standing things up?
Yeah, the analysts and the people who make money out of scaring people, they say that the misconfigurations are one of the biggest causes of outages, one of the biggest causes of security breaches, and so on. There are so many different, say, settings and things you can configure inside Kubernetes. Not generally, Kubernetes isn't secure by default. Like you can say, run this thing. An agent that is root on the machine then starts the thing running. So you can be root on the machine if you don't say otherwise. So you should say, I need to run this thing as a lower security user. And a lot of people will say, I'm not going to do that because I'm lazy and it works if I'm root and it doesn't if I'm not. And that's true of every kind of software delivery. So the first thing you need to do is be aware of what you're running. And the best way to be aware of it is to have software do that for you. I work now on an open source project called Kubescape, which has just joined the CNCF sandbox. It's a tool that basically can validate the state of your cluster, or it can validate the things that you're going to deploy for your cluster, and lend it against a bunch of different rules, which you can define based on either external guidelines, so the NSA and various other government organizations that publish things to say, here are some best practices for how you should manage your Kubernetes environment. And then you can validate, say, hey, that matters to me, that doesn't, and so on. That handles the sort of the easy case of the configuration of things. Now we also have to deal with the fact that we are running software, which in large part comes from third-party sources. You're not generally building your own Postgres container, you're taking it from someone else. And it's so much easier to run software than it used to be. You now have all the same problems that you had, but they're scaled up. What are you going to do with vulnerabilities? What are you going to do with the fact that this particular, so like it's easy to keep them all at the same version, but if you have a CVE now, you might have 10,000 containers that can be exploited. And so then you also need like Kubescape's functionality for handling vulnerabilities and looking at what's on each machine and what needs to be remediated. And we're doing a bunch of work at the moment in that to make sure, to make it possible to tell people, like all of a sudden, you do any kind of security scan on a machine and it's going to say everything is broken. There's 10,000 vulnerabilities in this machine or something. But it turns out maybe only a few of them are really important to deal with straight away. And some of them are exploitable or some of them are in a code path that gets run frequently. So we're putting a lot of work at the moment into how we can prioritize what things you need to fix. So you do need to be aware. That's true of any environment, but it's a lot easier to do it programmatically and know what's going on in an environment like Kubernetes.
Yeah, that makes sense. One thing that I want to make sure I kind of get this right. Somehow I ended up spinning up a service where people could access it from the outside, and that wasn't my intention at all. I wanted only employees to access it.
You are one of today's 95% misconfigurations.
And yeah, yeah. The thing that impressed me was not that I messed up Kubernetes, that was very obvious, but the thing that impressed me was that the IT or cloud platform folks at my company reached out to me in maybe like 5 minutes or something. I mean, it was unbelievable, like ambulance level turnaround time. And they're like, "Hey, you have this service?" And I was like, "Yeah, pretty proud of it." And they're like, "Oh yeah, so it turns out anyone can look at your website right now." I was like, "Oh, okay, let's turn that off." And I was just so impressed with how quickly, so I started asking questions, and they were saying that they have basically they have this monitoring system, and it goes to this database, and then there's a trigger, and it, DM them on Slack, and then they DM me on Slack. The thing was just phenomenal. And it kind of showed how important security is and how you could do it right, and what the value there.
My company ARMO builds such a system on top of the Kubescape engine. But the specific things that I think make Kubernetes more of a concern in this kind of environment is if you think about deploying your software on machines in the old days, like if someone had found a way to get a shell on your machine 20 years ago when you were hosting something, it's unlikely they would be able to influence any other machine on the network. Whereas today, if you're on a machine that runs Kubernetes, it's very easy to say, right, I've got onto this machine. Chances are that somewhere on this machine there's some network credentials which I'm able to use to, like, I use to call into my cloud provider to pull an object or something. If those credentials are not adequately scoped, then I can instruct the cloud provider to spin up more machines and start mining Bitcoin. Or if the Kubernetes API objects are not correctly configured, I can say, connect to the Kubernetes server, tell it to start running 10,000 pods to start mining Bitcoin. There are so many ways that I have a simple breach and someone can read my web server can now turn into some other kind of problem because we have this automation. And it's the fact all this automation is here that means you have to pay more attention to securing these environments than you did when they were lesser concern.
Yep, that totally makes sense. Yeah, I mean that's a attack that I hadn't even thought about. But you're right. I mean, next thing you know, you're spending like 100K a month or something on cloud so that someone else can get a bunch of Bitcoin. It's
It's always Bitcoin.
yeah, not Monero or anything. It's always Bitcoin.
I think that's just, Monero's just diet Bitcoin as far as I'm concerned. So.
Yeah, that's the only other one. Oh no, there's Ethereum. I don't know as much about that.
It's such a shame because the cryptocurrency has such practical use cases and can make banking available to so many people for whom it was not otherwise available. But we've just ended up burning a whole bunch of electricity, pushing up the price of graphics cards, and enabling crime. And it's hard for regulators to see past all of those things to the good in this. And I don't know how we can separate those two things and make a good out of it.
Yeah, I feel like I can say this now. It's like the body has been cold long enough for me to say this, but I always felt like, Web 2.0 is awesome. It's like all this interactive media, all this cool stuff, and you're seeing like underground people coming out from the underground and going viral and everything. And then, in my opinion, money kind of ruined it. And now it's like, oh, I have to make my show title in all caps so that I get more clicks, or oh, I need to I have to be on this platform or that platform. And you were constantly getting emails like you need to be on TikTok, and so it's just become very commercial. And so I always thought Web 3.0 was like, let's take the thing that ruined Web 2.0 and let's start there. Let's like build a castle around it. It's like, let's start with the big money.
Again, I could fill another podcast with opinions on this and so on, but in deference to your listeners at this point, I'm just going to make the face, the oh my god, I'm a YouTube thumbnail face, which they won't be able to see. Great radio here. That's the trouble with podcasts.
Yep. But the mining Bitcoin thing is hilarious. It's a tragedy though. It can get extremely expensive.
Yeah, it's made it possible to profit from cybercrime in a way that wasn't hugely relevant years ago.
Well, I was just gonna say, on the other side of the fence, what happens when someone gets a $100,000 bill? I mean, I don't know if you're at liberty to talk about this, but I always was curious. Someone gets exploited in this way, and it's someone like us. We don't have $100,000 sitting around, and then Google comes like trying to collect. Like, what actually happens there? If you could say.
Again, I don't work at Google. I did for some time. I don't I wasn't involved in anything like this explicitly, but I have seen a lot of stories with cloud vendors, not just Google, but all of them basically say, like, if it's an honest mistake, or if there's something that could be tracked down to a bug or something that probably shouldn't have happened and it was detected soon enough, then in a lot of cases the vendor will write the bill off. And that's generally a goodwill calculation as well. If you as an individual find that someone has exploited you and done a certain thing, and you don't feel you did anything wrong, and you have a big enough megaphone on the internet, you can probably make enough noise to put people off that vendor, such that the vendor will say, I'm going to eat that loss myself.
That makes sense. I bet they also have like certain pattern recognition things. So if they see 10,000 pods mining Bitcoin, they probably can even reach out and tell you something fishy is going on. I mean, I wouldn't count on it. I wouldn't make that your security plan, but they probably have something like that.
Yeah, and again, there are some distinctions that may have applied at Google. I'm not 100% sure, but you don't necessarily want a vendor to know what you are running in your VMs. Like, there is a trust boundary and so on. Like, you can do whatever and know that the people aren't looking in it. And there are lots of reasons, good and bad, why that is the case. But in general, if you're running something on a cloud, the vendor knows how much CPU you're using, but they shouldn't be able to see what is running. Unless, of course, you do something like install an agent which exports logs or whatever, and you make a choice to do that. So some information is available, and they can use that. And again, pattern recognition, perhaps, if all of a sudden nodes start sending out network connections that they weren't before, that is something that you may not necessarily want the provider to be looking at what is in those connections, but they could ping you and say, hey, all of a sudden your machines are spraying out traffic that they weren't before. That's a thing you should go and look at. So somewhere in the middle is the answer. You do have to have some responsibility there yourself.
Yeah, that makes sense. So we talked about ARMO and Kubescape. So definitely, folks should check this out. So, in terms of Armo the product, is there, we do have a lot of folks who are working professionals, who are Kubernetes users, who I think could benefit greatly from this. We also have a lot of students who are learning, and they want to, you know, for them it's like Job Simulator 2023. And so, is there like a free tier at Armo? What are some of the options for them?
Yeah, so Kubescape is an open source project. It's the thing you run inside your cluster, and it generates reports and so on, and that's entirely open source. We do see a lot of people learning and students and so on coming and wanting to get involved and hack on the project as well, which is fantastic. The backend service, which visualizes things and shows you here's the state as it was yesterday and today and tomorrow and so on, that is the ARMO platform. That is free for up to 10 worker nodes, and that's free forever. So if you're running at a small scale or experimenting or so on, we're more than happy for you to connect up there and visualize and see what's going on. And it also lets you see the configurations of access control inside your clusters and so on. And then obviously the bigger you get and so on, we'll talk to you about pricing plans. But overall, the Kubescape project is trying to build out security tooling, and we want to be a sort of an end-to-end platform that helps you secure your Kubernetes environments. And we saw at ARMO a number of security vendors were doing stuff in this space, but it was really just sort of an afterthought. It wasn't open source, or it wasn't the key business. And the difference we're doing is we're committed to making everything we have open source. Like, we want this to be a platform that's adopted just like many other add-ons for the Kubernetes ecosystem are today. And if we get to a point where it turns out that you're happy enough running just the open source things, we get a lot of people who are running it in their CI pipelines or as a GitHub action or something. They never touch the service that you can choose to pay for, and that's great too. Like, we really want this to be accessible and available to everybody.
Cool. That makes sense. And what about the company? What is something kind of interesting that, kind of sets Armo apart from other places to work? It could be, certain outings you do. It could be a travel policy. It could be your mascot. What is something that sets you apart?
Yeah, well, almost everyone is in Israel, and I'm in New Zealand. I think that sort of sets us apart enough to some degree. Yeah, is that
So wait, how did that happen?
how how that happened was I did have an intention to be back in England, and family situation has sort of made that unlikely at this point this year, at least. But overall, it was a case that they're building a remote company, and this is sort of a way to demonstrate that. Like, they have had a core of people, and everyone, when you say Israel and cybersecurity in the same sentence, everyone sort of builds their own opinion in their head. But there's a lot of work gone on in terms of training people up in that part of the world to be experts in this space. But then obviously interacting with the Kubernetes ecosystem. Like I understand security, but it wasn't my professional background. My background was in Kubernetes, and my background was in DevOps and so on. And those are the people that they're targeting. And I was the best person to help them with that. And it wasn't a problem to them that I was going to be working remotely and attending events and doing online stuff and so on. And they've been really great about that.
Cool. And so we do actually have a lot of listeners in Israel, which is awesome. But for folks who aren't in
Shalom.
Israel, yeah, that's right. For folks who aren't in Israel, are there more remote opportunities? Is there a careers page that they should check out, and what does that look like? And also, are there internships for students, and what does that look like? They're kind of two separate questions.
Mm-hmm. There is a careers page. I am hiring at the moment and may still be at the time you're listening to this podcast, but I don't know whether or not the job description is up. But I'm looking for another developer advocate or someone for our team who's writing and telling people about interesting stuff in the Kubernetes ecosystem. So find me in the show notes and ping me if that's something that you're interested in. In terms of internships and so on, like we have been as a CNCF project participating in a thing called the LFX Mentorship Project, which is the Linux Foundation basically pay 3 or 4 times a year a stipend to a bunch of students around the world to contribute to open source projects. It's a little bit like the Google Summer of Code, if you've heard of that. We're looking at possibly participating in that too. But that's a way where we basically give a chance to people to get involved in a paid capacity in an open source project and build up their skills working with the community, working with the maintainers of a project, and so on. We are currently working with 3 different mentees, and we're getting some really good results. And hopefully, we're helping them in their journey as they work towards becoming professional programmers.
Very cool. That is awesome. Yeah, I mean, I'm fascinated with Kubernetes and security. I think that that incident that happened to me and the fact that they turned it around so quickly at my company showed me how dangerous it is, also how important it is. I think it's a great area. Folks out there, if you are graduating soon or if you're looking for internships, other opportunities, definitely check out the show notes. We'll have all the details in that. And yeah, I just wanted to say thank you, Craig. This is a amazing interview. You kind of covered really Kubernetes start to finish. We talked about how people can get started. There is a lot of complexity. We didn't have time to dive into like Helm and all these other things, but there's a rabbit hole there, and maybe there's a future show there. But we gave folks the right ingredients to get started. And I could tell you, I kind of wish these tools were there. I always did distributed machine learning. My whole PhD was on that, and I really wish that these tools were there because I was manually copying C++ binaries around and using Slurm and MPI and all these painful things.
Unzipping jar files.
Unzipping jar files. Yep. So definitely, I think it behooves people to really learn Docker and Kubernetes as early as possible, just like it behooves people to learn source control. And so, yeah, definitely, if you have any questions about anything you heard, don't hesitate to email us, programmingthrowdown@gmail.com. We can also kind of pass your question around. Otherwise, you could also reach Craig on Twitter. You can follow Craig and see what he's talking about on Twitter, twitter.com/CraigBox. And we'll put all of that in the show notes.
I used to host a very popular podcast on Kubernetes, and since leaving Google, I have pivoted to writing a mediocre newsletter, which has my thoughts on the Kubernetes ecosystem every now and then. And until such time as I am more permanently behind a mic again, I will encourage people to catch up with the Kubernetes ecosystem and news in the industry by reading the Substack, which you'll find a link to on my Twitter page as well.
Great. And we'll put that link on the show notes as well to save people a click if they want to go straight there. One last kind of administrative thing. Ironically, we are actually uploading all the episodes to YouTube. I talked about this on my Twitter. The reason we're doing it is to get captions. YouTube is amazing at giving captions in a zillion different languages. I'm constantly getting emails, hey, do you have captions? Do you have captions in Russian? Do you have captions in Spanish? And Transistor, which is our hosting company, recently offer, or maybe they've always had it, but I recently found the YouTube integration button, hit the big red button. Now all the episodes are up there on YouTube. Definitely give it a listen, especially if you're wanting to read what we're talking about. Thank you again, Craig. It's an awesome time. I really appreciate you kind of coming on the show, and I really look forward to seeing how things go at ARMO. So thank you so much.
Thank you both again very much. It's been an absolute pleasure.
Music by Eric Barndollar.
Programming Throwdown is distributed under a Creative Commons Attribution Share-alike 2.0 license. You're free to share, copy, distribute, transmit the work, to remix, adapt the work, but you must provide attribution to Patrick and I, and share alike in kind.